Okay, so let's get started with this chapter, new chapter, triangles. You studied triangles in the previous year also, right? Ninth standard. What did you learn about triangles then? Do you people recall?
Congruence of triangles.
Yes, absolutely. You learned about the congruence of triangles. What do you remember about congruence? If we had two triangles, let's say ABC, we had two triangles, let's say ABC and PQR like this. When would you say that these triangles are congruent? Of course, congruent triangles will not have a difference of shape like this. It will be similar size, something like this. Yeah, so when would you say that these two triangles are congruent? When all the angles, the corresponding angles basically, and the corresponding sides are equal. They are same shape, same size. What does it mean? AB is equal to PQ, AC is equal to PR, and BC is equal to QR. So all the sides are equal. And angles are also equal. Angle A is equal to angle B, B is equal to angle Q, C is equal to angle R. Sides are also equal, angles are also equal. That's when we say them, they are congruent. And what was the symbol for representing the congruence of triangles? To equal to sign and this tilted symbol, something like that. Okay, that is your symbol for congruence. And you recall the order in which we write this A, B, C, P, Q, R. It's very important. If I write A first and if I write P first in this one, that means A is corresponding to P. P corresponds to Q, and same way C corresponds to R. Okay. What were the different rules of congruence? Can anyone tell me? What rules did you learn for congruence?
SSS.
SSS, SAS,
Okay,
AAS.
SSS, SAS,
RHS,
AAS.
AAS, or ASA. Both are same basically. Two angles and the side.
RHS.
And the last one, RHS. So these are the four rules which you learned.
Sir, are they same, sir?
AAS and ASA.
Yes.
See, we can't
Yes,
say that
sir.
they are same, but any triangle where you can prove that, any triangle which you can prove the congruence using AAS, you can also prove it using ASA, because you see two angles are equal. So if two angles are equal, third angle also automatically becomes equal, right?
Yes, sir.
So because of that, what happens? Let's take an example. Let's say I'm saying ABC and PQR. What happens in AAS and ASA? One side is equal. So let's say I know that AB is equal to PQ. Okay, AB is equal to PQ. So yeah, what I was saying is in these two triangles, let's say I'm telling you that AB is equal to PQ. And for AAS condition, what do you need? You need two angles and a side. So let's say I know angle B and angle C are equal to Q and R. What I mean is angle B is equal to angle Q, angle C is equal to angle R, and this side is equal to PQ, AB is equal to PQ. So this will satisfy the condition AAS, right? Everyone agrees? Angle
Yes,
side.
Yes,
Now,
sir.
with this same information given, can you not prove? Because if angle B is equal to C, I mean to say, if angle B is equal to Q and C is equal to R, if two angles are equal, can the third angle be different? It has to be same only, no? Because angle sum property, some of the three angles have to be 180. So third angle will also be same automatically. So we can say that angle A is also equal to angle P. Now, if I know that angle A is equal to P, I already know that AB is equal to PQ, and I also know that angle B is equal to angle Q. So this satisfies the condition ASA, right? So what I was saying is, whenever you have any situation given where this information is given, and if you are able to use AAS, you will also be able to use ASA. That's why these two are not different conditions, but same. Okay. But remember them. Like if you are using AAS, you have to prove this BC and AB is equal to QR and PQ. Same way, if you want to use ASA, you have to use the particular angles and the side. Angle A, AB, and B will be equal to P, PQ, and Q. Okay. Nitya, it was your question. Is it clear?
Yes, sir.
All right. So this was about what you had studied in the previous class. That was congruence. And remember, congruence is not only with triangles. Congruence can be with any shape. So congruence means the shape of the object is exactly same, and shape is same, size is also same. So if I have, let's say, a rectangle, if I have a rectangle, let's say this is 4 centimeter, this is 2 centimeter, and I have another rectangle which is also same dimension, 4 centimeter and 2 centimeter, then these two are also congruent to each other. If I have two circles with the same radius, then they are also congruent. You can have a pentagon with the same size and shape, then they are also congruent. So congruence is not something which is related to only triangles. It could be for any shape. Okay. All right. So, but in this chapter, you're not going to learn too much about congruence, but something about similarity. Similarity is similar to congruence up to some extent. What happens in case of similarity? Shape is same, size may or may not be same. It may be same also, may not be same also.
Angles, sir.
Yes. See, when I say that shape is same, it means all the angles are same. And when I say that size is same, that means all the sides will be same. But if the size is not same, still it can be similar, but there has to be a condition for that. What is that condition? They have to be in proportion. Sides have to be in proportion. So let me explain that. Let's use a simple triangle itself, but remember this rule applies to other things also. Or let's take a simple example for example, circle. If you take a circle which has a radius of 5 centimeter, if you draw another circle which has a radius of 2 centimeter, don't you think these two figures are similar? This bigger circle is just the magnified version of the smaller one. So the shape is same, but the size is different. Same way you can take an equilateral triangle.
Sir, then every equilateral triangle we draw will satisfy this condition, no, sir.
Yes, very true. Very good. Actually, that is what happens. Every equilateral triangle, they are similar to each other because all of the similar triangles will have the same angle, 60 degree. But size may be different. Some of them may be smaller, some of them may be bigger. But since all the sides are equal, they will also be in proportion. We will see about all those things after learning about the rules of similarity. Just like there are rules of congruence, there are rules of similarity also. Okay, so all the squares in the world, they are also similar to each other. All the rectangles in the world, they may not be. All the rectangles may not be similar to each other. Can anyone tell me why?
Sir, all the angles are equal, okay, sir. Then why it can't be?
Think about this rectangle, these two rectangles. Do they look similar shape?
No, sir.
So this length is too big compared to this length, but breadth is in proportion. So they are
Yes,
not
sir.
similar. Okay, so the sides have to be in proportion, only then you can call them as similar shapes. Okay, so all the squares, since all the sides are equal, no matter what side, if you pick this 5 centimeter and if you pick this 8 centimeter, you know that all the sides are 5 here and all the sides are 8 here. So they are in proportion with each other. What I mean by that, I can say, let's say the square is ABCD and let's just PQRS. What you can say is AB by PQ is 5 by 8, right? But same thing will be happening with BC by QR also. BC by QR is also equal to 5 by 8. So all the ratios are equal to 5 by 8. That's why all squares, I mean, in this case, I have taken example of 5 and 8. The numbers could be anything. But you understand that since all the sides are equal, they will all, the ratio of the corresponding sides will always be equal. Okay, that's why all squares are similar to each other. Yes,
Sir,
go ahead
I
now.
didn't.
Go ahead now. Tell me what's your doubt. I couldn't hear you. Say that again.
Sir, I didn't understand what have you said now.
About the squares.
Yes, sir. That
Okay.
ratio, why are you dividing?
Okay. See, what I said is these all the squares in the world, no matter whether they are smaller or bigger, they will be always similar shape. They have similar shape, right? All the angles are equal, 90 degree each, and all the sides, they are in proportion with each other. Okay, the sides are in proportion. When I say in proportion, what it means is, it means that AB by PQ is equal to BC by QR is equal to CD by RS is equal to AD by PS. All the sides are in proportion with each other. So this side and this side, they are in proportion. This side and this side, they are also in proportion. Because they are all equal, no? In a square, all the sides are equal. So they will always be in proportion. That's what I took an example. I said, let's say this is 5 centimeter and this is 8 centimeter square. All the sides are 8 centimeter. Then if AB by PQ is 5 by 8, BC by QR will also be 5 by 8. CD by RS will also be 5 by 8. AD by PS will also be 5 by 8. All of them will be equal to 5 by 8. That same ratio. That means they are in proportion with each other, with the corresponding sides. So don't worry about this. We will talk about this in more detail when we get to the triangles. So what I want you to understand, similar shapes means they have same shape, but size may or may not be same. but there has to be some similarity in their proportions. For example, when I took an example of a rectangle, if I take a rectangle like this, and if I take another rectangle which is like very long but the breadth is same, these two shapes are not similar, no, they don't have similar shape. So you can understand these two rectangles, they are not similar, but the squares are always similar. Equilateral triangles, they're always similar with other equilateral triangles because the sides will be in proportion.
So for circles, I didn't understand.
Yes, circle also, it's the same thing. The rule, of course, there is no angles or sides over here, but you can understand that the shape is similar. No, this is the bigger circle is just the magnified version of the smaller one. They have a similar shape. It has a smaller radius, it has a bigger radius, but the shape is similar.
Sir, then I have a doubt. Now, what if they both don't have the same center? Like, once that 5 centimeter circle is big and the 3 centimeter circle is like intersecting that 5 centimeter circle, then if you magnify, it cannot be equal, no, sir.
Charan, the position of the circle has nothing to do with it. Nobody said that you cannot move the circle around. No, I said these are circles. I can take this circle and move it from here to some other place. So when you magnify a circle, anyway, it will become equal to the other circle, no? If they are circle. This is of course my drawing.
Yes.
So they are not fitting together, but you understand, right? If it was a pure perfect circle, if you magnify it, it will become equal to the other circle. So you can understand it that way only. If you take one figure, if you can magnify or shrink it to make it exactly same as the other one, then those two figures will be similar to each other. But if you magnify or make it bigger or smaller, if you are still not able to make it to the same shape, then it will not be similar. It's a very good example to understand. Let's say if you have a button which you can move to shrink it or make it bigger up to whatever size, and if you can make both of them equal. Okay, so confirm guys, do you people understand the concept of similarity?
Yes.
Yes, sir.
All right. So let's get to our NCRT. Let's say what do they have to say? Yeah, similar figures, you can understand. Circles, they are similar. Squares, they are similar. Equilateral triangles can be similar. You can have even polygons of any shape. They can be similar to one another as long as you can magnify it and make it exactly same shape, the size like this. If you can magnify it to this one, then. And when we are saying that we can magnify it to up to this scale, means that is a general language. In mathematical terms, we call it as the sides are in proportion with each other. If I take an example, let's say this is 2, this is 4, this is 3, 6, 5, 10, and let's say this is 4 and 8. You see, right? All the sides are in proportion. If you just take this one and double everything, then it will become equal to this much, no? If you make this size double 2 times, it will become equal to this shape, So we can magnify this one to make it equal to this. That's why these two will be similar with each other. But like I took an example of a big long rectangle like this and a short rectangle, I cannot magnify it to make it. Even if I magnify this one, this length will not be equal to this length and breadth. They will not exactly fit with each other. You can understand the idea, right? Yeah. So these examples, you can take the picture of same Taj Mahal and you can shrink it, make it bigger, and still they will be similar with each other. So this is the definition of similarity for polygons. 2 polygons of the same number of sides. It could be a quadrilateral, pentagon, hexagon, whatever you want. It can be similar as long as the corresponding angles are equal and their corresponding sides are in same ratio or they are in proportion. So in your book, they have given you this activity. There's a bulb hanging over here on top, and exactly below that, you take a cardboard or something and you make some polygon shape in it, cut it out. So the light which goes through this will make some polygon over here. No, it will be a little magnified. Can you understand that? It will be bigger than the shape of what you have cut it out over here. The shadow of this thing will be bigger, right?
Yes, sir.
So this cutout polygon and the polygon which you see here on the table, they will be similar with each other because it's the same magnified version of this polygon ABCD. For example, take these two shapes, these two polygons. You see angle A, angle P, same. B and Q, same. C and R is also same. D and S is also same. So all the angles are equal. This is the first condition. Angles, corresponding angles have to be always same. Only then the shapes can be same. If it has straight lines, of course, other than circle. Angles have to be same, only then figures can be, corresponding angles have to be same, only then shapes can be similar. That is the first condition. Other condition is sides should be in proportion. You see this AB is 1.5, PQ is 3. Is it not double of this one? So if this is the double, other sides also have to be double of each other. Like this is 2.5, this is 5, 2.4, 4.8, 2.1 and 4.2. You can see all the sides are double of their corresponding sides. So what is the ratio of AB by PQ? AB is 1.5, PQ is 3. So you can say the ratio is 1 by 2, no? So all the sides are in the ratio of 1 by 2. That is why these two figures are similar with each other. Look at this square and this rectangle. Remember, this is 3 and 3, and this is 3.5, so this is a rectangle. Are they similar, these two figures?
No, sir.
Everyone understands that? They are not similar because all the sides are not in proportion with each other. These two sides are like BC and RQ, they are equal. So if these two are equal, all other sides had to be equal. Only then they will be similar. Or in fact, in this case, if they are equal, they will not just be similar, but they will become congruent also. But here they are not. This one is very easy to figure out. These two, do you think these two are similar with each other, similar to one another?
Yes, sir.
They are similar.
Yes, sir.
No, sir. Since the angles are not equal.
Sir, but the ratios are same.
Yes, but I said no. The angles will always have to be same. If angle is not same, then don't even look at the sides. So here these angles are 90°. These angles are different. Do you think if you magnify or shrink it, will you be able to make it like this shape? If you magnify this or make it smaller or do anything, remember all of this you have to magnify in same proportion. It's not like you can stretch it from one side. You can't do that. Only thing is you can magnify it using a magnifying glass, zoom in or zoom out. Can you do it, make it look like this shape ever? No, because these angles are different. So these two figures will never be similar, even though the sides are in proportion. So the necessary condition is angles will always have to be equal. If it has straight lines, then angles have to be equal and sides have to be in proportion with each other. So we have come to this exercise 6.1. This should be very easy for you people. Let's finish it right away.
Sir,
Yes, tell me.
sir, if there's a there are two triangles, we should find whether they are similar or not. All the angles are equal set. Then sides all are here. In one triangle, say another triangle, all three are different, but they are proportional. So how can we find this side is this side? This side is proportional.
Okay, Charan, your audio is breaking, so I couldn't hear you clearly. Repeat your question slowly. You are saying there are two triangles.
Yes, sir. And the angle of the triangles are equal, sir.
Equal. Angles are equal. You mean to say the corresponding angles are equal?
Yes, sir. Now the sides of the triangle are in proportion to the other triangle, sir.
Okay, so let's say angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Okay, then
So now we have sides
we have
like sides
sides.
length of
Okay, is it me only or everyone is not able to hear Charan? Are you people able to hear Charan clearly? Okay,
sir. Now I
try to say it
clear.
slowly. Slowly. What about the sides? What is your question?
Now the sides of the triangle ABC are there. Is proportional to the sides of the triangle PQ are there.
Mm-hmm.
So how can we to find that they are similar, prove that the sides are proportional to this. This side is proportional to this.
Okay, see, I'm not very sure whether I got your question 100%, but let me see, let me try. Okay, so you want to understand whether these two triangles are similar or not. You know that the angles are in proportion. Okay, see, about this, specifically about the triangles, we will learn how to figure out whether the triangles are similar or not. The condition for checking whether some triangle is similar or not is very easy. We'll learn that. Okay, and just for now, if you know that all the angles are corresponding angles are equal, that alone is sufficient to tell that these two triangles are similar with each other. Don't even need to look at the sides.
Yes, sir.
Okay, that is one of the condition actually. AA or triple A. If two angles are equal, of course, third angle will also be equal. That's why we can just call it as angle, or we can write it as AAA. That is angle. Corresponding, all three corresponding angles are equal. That means the two triangles will be.
Sir, is there any congruence, sir, like that?
No, not congruence. This is a rule for similarity. This is a rule for similarity, AAA or AA. Both are same.
Yes, sir.
We will learn about that. Okay. So, and remember, I'm talking only about the triangles right now. Like in case of rectangle, I told you all the angles are still 90 degrees, but still when the sides are not in proportion, they will not be similar with each other. So this rule does not work for rectangles or any other polygons. This AAA or AA rule works only for triangles. Only if just by knowing that the angles are equal, that is sufficient to know that the triangles are similar. Okay. Don't even need to think about the sides in this case for a triangle. All right. Let's move on to our exercise 6.1. So everybody write down no need to write all the words, just write down the exercise and the question number and write down the answer for the first one. Tell me what will be the answer. All circles are congruent or similar? What is it?
Similar.
Yes, of course. All circles are similar. They will not always be congruent. When will two circles be congruent? Only when their radius is equal. But if the radius is not equal, then they are similar. Similar is your right answer. Okay, second one.
Congruent.
All squares are similar or congruent. So we talked about that. No? If you have a small square and a big square, will they be congruent or similar?
Congruent.
Congruent means they have to be exactly same size also, just like triangles.
They
Congruent
can be similar, sir.
Sir, but their angles.
Yeah, that's what we said, no? Angles are same, but their sides are in proportion, so they are similar, not congruent. Congruent means they have to have exactly same size. We are talking both the same. If you pick one square and put it on the other, it should exactly fit on top of it. Then it will be congruent, just like congruent triangles. So we are talking about all squares, right? So if the one square is small, other one is big, or even if they are same size, they are still similar, right? So since we need to talk about in general all the squares, so all the squares are similar to each other. Is it clear?
Yes, sir.
Okay. Third one.
Equilateral.
Yes, all equilateral triangles are similar. Did you people understand why isosceles triangles will not be similar? Okay, let me explain. See, I can have an isosceles triangle where this angle is 40 degree. I can have another isosceles triangle where this angle is 70 degree. Okay, so you can see, right, the angles are different. The corresponding angles are different. One has 40, other one has 70. Let me make it more extreme. Let's say this is the isosceles triangle which has only 10 degree. So do you think I can magnify this to make it look like the other one? No, right?
No, sir.
Even if I magnify, the angle is always going to be 10 degree only. The angle never change. When we magnify or shrink something, the angle remains the same. Only the size of the sides will change when we magnify it or shrink it. So isosceles triangle, angles are different. Angles may be different. That's why they will not be similar. But in case of equilateral triangles, we know that all equilateral triangles in the world, they always have angles is always 60 degree only. All the angles are 60, 60, 60, no matter whether it's big or small. Right? So if you magnify it, you can make it to this size and the angles will be same. Next one.
Equal and proportional.
Yes, absolutely right. Two polygons of the same number of sides, they will be similar if their corresponding angles have to be equal. Remember, like I said, for polygons, both the conditions have to satisfy. Only then they will be similar. Angles have to be equal and sides have to be in proportion. Okay. Can you people give me examples of these similar figures? Two examples.
Circle. Will equilateral triangles be similar?
Yes, like any two circles or equilateral triangles, use that itself. Okay.
Circles also, no, sir.
Yes, yes. Circles also, they will always be similar. Circles, equilateral triangles, squares, they will be any square shape objects, they will be similar to figures. Anything else?
So will rectangles be considered not?
Yes, rectangles whose sides are not in proportion. You can consider them. Or a trapezium and a parallelogram, square and a rhombus, they will not be similar. Move on to the third one. Look at these two. Tell me if they are similar or not.
No, sir.
They are polygons, right? They are polygons, and for polygons, they have four sides, but their angles are not equal. Since their angles are not equal, they will never be similar, even though the sides are in proportion. Okay, that's it. So we have completed our first exercise, 6.1. Tomorrow we will start a very important concept, similarity of triangles, in more detail, and we will study something called basic proportionality theorem, theorem 6.1. So anyone who is interested, try to read through this theorem in home and try to even read through the proof of this theorem over here, because once you have gone through it, it will be easier for you to ask me doubts tomorrow, or you'll understand it better. Okay, so try to do that. Try to read through this on your own. And this theorem is very important for your exam perspective. You'll get lots of questions from this question, and you may be asked to prove this theorem also. So yes, that's it for the maths class.